Our next speaker today is Eric Halfon from Analog Devices, who brings extensive experience in cybersecurity solutions. As part of ADI's Cybersecurity Centre of Excellence, Halfon has taken on the role of Security Systems Manager for Industrial Solutions. Leveraging his experience as a cybersecurity program manager in the defence industry, Halfon is focused on developing leading security solutions to meet key market demands in industrial IoT. Security is often considered a feature or point solution necessary to deploy the next IoT solution. However, what role could it play in accelerating innovative solutions to enable sustainable global ecosystems, protect workers and consumers alike, and build healthier communities? Building the next digital solution in markets such as electrification, 5G, digital health, and smart manufacturing requires standardization of security requirements and the ability to uphold uniformity for interoperability within highly constrained endpoints. In his presentation, Halfon will explain how security approaches can free teams to build a better future. So without further ado, I'll hand over to Eric.
Yeah, thank you, Joe, and thank you everyone for tuning into this. Before I jump into the presentation, I just want to share a little bit more about my role and in Analog Devices. I get the opportunity to have a very forward-looking approach for the security needs of our markets and across all of ADI's businesses. But for this presentation, I get to take that experience and also merge it with something that's very passionate interest of mine. That's environmental causes and social justice. So with that, I want to introduce the overall challenge and then eventually bring it back to how security plays a substantial role in our environment. So this slide here is a bit of an eye chart, but I'm going to make it easy for you to decipher. And for the purpose of this presentation, what's important here is on the left-hand side, you'll see what are energy sources or the generation of energy. And then on the right-hand side in the pink blocks, you'll see how energy is utilized. And then on the far right, in the gray boxes, that's where how the energy is effectively utilized and the rejected energy or energy that is wasted. So there are 5 key points I want to make here. And the first being is that rejected energy is most substantial. It's contributing to more than twice that of used energy. That as well as on the energy generated portion, and that's that orange block. That's electricity generated through other means, and as you can see, very little of that is used. There's a lot of rejected energy from electricity generation. Another key point here is that the transportation block, which is that lower yellow block or pink block, is the biggest contributor to some of our concerns and has a substantial portion of that being rejected energy. And transportation and coal both combined to make up the largest contributors to carbon today. And finally, when we look at sustainable sources of energy, it's still a very small percentage of the overall energy picture, and it's growing slowly. Today, it's only 6%. So hopefully, this paints a picture of the magnitude of the challenge that we have, and now I want to start talking about how IoT plays a big role in solving these challenges. So first to note, there are three ways to substantially impact sustainability, and one's reducing demand, and that's through virtualization and smart solutions. Another is increasing efficiency, and whether the power consumption of electronics, using renewables, and the effectiveness of batteries. And then the third way is handling pollution. And That's through monitoring and sequestration. So all three of those IoT solutions are quintessential to impacting sustainability, and whether that's through the measurement of operations, or the virtualization of operations, or the design of themselves to make the processes more efficient. And when we look at the electronics megatrends, we early on saw the introduction of centralized computing. That went a long way in optimizing G&A functions at a corporate level, and then we saw the introduction of edge, internet, and communications driving virtualization. And today we're in a day where we have AI solution IoT systems, and those smart systems being embedded into infrastructure, into the physical infrastructure to greatly impact sustainability on all three of those points previously mentioned. So the message here is that the core technology to making these impacts really reside in edge computing and IoT solutions. And looking at how we're making these changes, it's both on an incremental level of making improved efficiency, optimizing current processes, and it's also around introducing new processes and the transformational changes that provides. And a good example of that, for instance, is the automobile, and taking a combustion engine and now using electronic motors to power that automobile. So one thing to note here is all of its innovation, though, whether it's incremental steps or transformational steps. And I'm going to come back to this point of taking a lot less energy to transmit the information than it does to move physical entities, and that's the quintessential part of introducing smart solutions, IoT solutions, into all of the infrastructural elements. Another look that I want to provide is how our megatrends today not only provide a technology transformation, but directly impact the role and play a significant role in sustainability and social impact. And so the four megatrends that I want to introduce are 5G, digital health, autonomous transportation, electrification, and automations and smart supply chains. So all four of these are common megatrends, but they do tie directly to making an impact. And so taking 5G, for instance, to start with, and how it's incorporating a wireless infrastructure where new critical infrastructure can start getting connected, reducing the need or eliminating the need for copper wire, for instance, and reducing waste. Also, exponentially expanding the opportunity for building infrastructure in already developed areas, but also undeveloped areas. And so the impact there is twofold. It's both sustainability as well as the social impact of that. With digital health, we're looking at introducing clinical grade medical equipment outside of hospitals, drastically adjusting how affordable healthcare can be, but as well as the accessibility, and expanding the scope of accessibility. With autonomous transportation and electrification, this too is twofold. We're introducing renewable energy, but we're also changing the demand of transportation, and potentially how you might even own vehicles in the future with a shared model. And then on the On the automation and smart supply chain, this one directly affects worker safety and also has an opportunity to reduce waste. And coming back to the concept of taking a lot less energy to move data than objects. So each of these mega trends will make a huge impact and have an opportunity to make a huge impact, but it doesn't come without its challenges and market-driven needs. And that's driving faster, more dynamic life cycles, opening up the aperture for more contributors, whether it's existing companies or startups, and then also ensuring that new designs fit the application need and are designed for efficiency and reducing the waste. And to do that, we look at we've been turning for a long time to the role of different standards in industries and alliances. And today we're seeing introduction of many more alliances associated with these megatrends. And these alliances serve a critical purpose. And one for ensuring that markets are driving faster and more competitive innovation, but also addressing the aspect that IoT devices are embedded in physical infrastructure, and that in itself produces unique requirements and challenges. And so these industry standards and alliances are really there to ensure maintainability, reliability, and anything around future requirements and volatility with those. While opening up the aperture for more ecosystem partners. And it's important to mention here that security is an essential component of these standards. And as I tie the security elements or practices to the social elements, I want the audience to keep in mind how these industry bodies ultimately will drive designs and constrained devices, and the importance of keeping this in mind with security requirements. Before I get into that, though, I want to give one example of how the industry alliances are utilized today. And I picked O-RAN Alliance because it's fairly new, but it also is a great representation of how alliances can be used to solve these challenges and address the needs for innovation. And so O-RAN Alliance is an alliance that's introduced by the operators for the operators in the area of 5G infrastructure. And the 26 current members are listed there on the right, but it's also important to note there's 182 contributing alliance members in addition to that. So this alliance was formed to develop and encourage white box ecosystem and enable more ecosystem players to participate and innovate in, and really drastically changing the pace of innovation as well as that diversity. And they're doing this with through delivering a set of standard interfaces and a white box reference design. So now I want to transition more into the security role and some things to keep in mind as individuals and companies participate in these industry moves and industry alliances. So I've categorized it into three different areas, core areas. And before introducing how security impacts electronic waste, I want to talk a little bit about the challenges around electronic waste. So if you think about all of the different products introduced today, and consumer goods is a good example, and let's take cell phones for instance, cell phones, laptops. All of these electronics have a limited life cycle and eventually are disposed of, and hopefully disposed of in environmental friendly way, especially considering most of these devices have batteries. But recycling these components are very costly and very challenging and not very effective, to be honest. So there's a lot of ways this problem needs to be addressed, but we have an opportunity to reduce the extent of the problem by extending the usable life of products. And security becomes a key element of the architecture in order to do that. And that's through lifecycle management of a device itself, but also enabling second lives for products and avoiding the need to dispose of the usable product itself. And then of course, making sure the architecture supports um, a future-proof design, so updatability and a platform, a hardware platform where software innovation and software-defined solutions can take place. And so security and the security architecture of that needs to be something at the very forefront of these designs and thought process going into any new design. So moving on to the product waste standpoint, this goes back to the concept of constrained devices, and IoT exists primarily in a constrained environment when you're embedding sensors into different physical objects and products, and so a security concept that's intended to minimize cost and power. And that goes into a thought process of a system approach to security and looking at it from a risk standpoint, but also from the introduction of standards and supported algorithms, for instance, ensuring that the algorithms that are selected and standardized around are a subset of the total possibility. We don't. Oftentimes, it's easy to take a data center approach to these standards and say, okay, we're going to support 26 different algorithms. But limiting the amount of algorithms these constrained devices need to support can greatly reduce the physical size of the device and the efficiency of the device. So keeping that in mind, especially participating in these standard bodies. And then the final piece here is maybe more traditional approach to how you might consider security impacting social impact, and that's safety and security being synonymous, whether it's industrial automation or an autonomous vehicle, safeguarding user privacy, especially when we are thinking about digital health solutions. Secure by default. Not everyone has the same propensity to security as security experts might. So ensuring that it's not an option but a default goes a long ways in protecting the users. And then the intuitive and easy. That's not just at a user level. Designing products that are intuitive and easy to from a security IP or architecture standpoint to integrate into an application by other design teams, limiting or eliminating the need for adjusting the security functions of that so that vulnerabilities aren't accidentally introduced. And hopefully that ties security back to the overall message and the scope and role IoT plays in these problems at a broad scale. I want to close with just some security practices to keep in mind as it relates to enabling the sustainable global ecosystems. And some of these are pretty basic and known for many reasons, but just want to highlight these 5 principles. Conformance to industry standards, that's key for many reasons, but especially when ensuring default or minimum set of securities adhered to. Reusability, I think, goes a long way in in maximizing the application of security. So designing a security subsystem, for instance, that can be integrated into multiple applications will serve to reduce the design cycle time and help bring new solutions to life quicker, but also in a way that's already proven and certified. And size, this is big. Being able to size to the application and the risk, and that goes beyond just let's constrain what we're forcing to go into these devices, to also let's look at the risk the device has to the entire system and size the security solution to that risk. And that system approach also goes to the next block, which is implementing it at the right layers within the system. And finally, when we architect these designs, keeping in mind feature enablement, updatability, but also where this product might be able to live in the future, and architecting that for life cycle requirements, but also second life. So hopefully this provided some practical application, but it definitely is a topic that's near and dear to my heart. So I hope this provides some useful insight into future product discussions or designs and additional contribution to the current alliances out there today. With that, I'll turn it back over to you, Joe.
Thanks, Eric. Yeah, I think the link there between sustainability and security is something that's not always discussed, so it was great to hear more about that. For our listeners, that's all from Eric for now, but he will be back for the Q&A at the end of this forum, so if you have any questions for Eric, then please keep them in mind and we will ask them at the end of the session. But for now, thank you very much, Eric.